Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahir Rahmanir Rahim. Welcome everyone to the fifth class on SSC Physics, Chapter 7, Waves and Sound. In the previous fourth class, we have analyzed some wave-related examples from textbook. We have also discussed on sound wave. We have given the definition, how the sound wave is propagated through air, the mode of propagation. We have a demonstration experiment, bell in a bell jar, that illustrated the essentiality of presence of a propagating medium for the propagation of sound. And we also discussed about the audible sound frequency range for humans, and we also discussed about the characteristics of sound wave. Now in the fifth class, we will understand what is called reflection of sound. And reflection of sound can produce either one of the two effects called reverberation and echo. We will also inshallah determine and find an equation how to determine the minimum distance to hear echo, and we will understand how does bat fly in the darkness and the factors affecting the velocity of sound. What is the effect of temperature, humidity, density of the medium, and stiffness, rigidity of the material of the propagating medium on the velocity of sound. At first, we will discuss about reflection of sound. So reflection of sound is the phenomenon of bouncing of back of sound wave at the surface of separation between two liquid, gaseous, or solid media. So the reflection of sound can produce one effect when the reflected sound cannot be recognized separately from the original sound. If the reflected sound comes back to the human hearer so much quickly that the reflected sound cannot be recognized separately from the original sound, two sounds merge together, then this effect is called reverberation. And if the reflected sound can be recognized separately from the original sound to the human hearer, then this effect is called the echo. And to recognize the echo for humans, we need a minimum 0.1 second spacing or separation between the two sounds. So if there is a difference of 0.1 seconds between the time of production of sound and the time of capturing the echo sound, then human can be able to recognize the echo. So this 0.1 second is called the persistence time of hearing into the human brain. So this figure illustrates this reverberation and echo phenomenon. The effect of reverberation can be heard if the distance is less than 17 meters. So the time of coming back of the sound is less than 0.1 seconds, so the person cannot differentiate between the original sound and the reflected sound. But if the distance is more than 17 meters, the hearer can differentiate between the original sound and the reflected sound, and this phenomenon will be called echo. Now we will determine an equation to find the minimum distance to hear echo. Let's assume that a person is standing in front of a cliff, a solid barrier surface. He is producing a sound, and this sound reflects back to him. Now let's assume the distance between the cliff and the person is d. So the sound will hit to the barrier surface and then come to the hearer. So the total path traveled by the sound is twice d. So now we are considering that the total path traveled by sound should be twice d, and this twice d distance should be traveled in the time of 0.1 second, because 0.1 second is the minimum time required to recognize echo. So the given time here is 0.1 second. From the simple formula of velocity, we know that velocity can be determined by dividing the travel distance by given time. So the sound velocity can also be determined by dividing the travel distance or traveled path by time. So here we see the total distance or path traveled by the sound is twice d, while the given time is small t. So the velocity of sound should be 2d by t. So from this we can find the distance between the person and the cliff, d by vt by 2. So from this we get the formula to determine the minimum distance to here echo, d equals vt by 2. So now we want to determine the minimum distance to here echo at 0 degrees Celsius temperature. We know that the sound velocity at 0 degrees Celsius is 330 meter per second. So when we put the values, we get the minimum distance to hear the echo as 16.5 meter. But we know at 20 degrees Celsius temperature the sound velocity is not 330, it increases to 342 meter per second. So what will happen to the minimum distance to hear echo? The minimum distance to hear echo will also increase. So if we put the values by the velocity as the velocity 342 meter per second, then we find the minimum distance to hear echo at 20 degrees Celsius as 17.1 meter. So how the velocity increased at increased temperature? We know that for per degree Celsius temperature increase, the velocity of sound increases by 0.6 meter per second. So as a result, 20 times 0.6 equals 12 meter per second is increased to the initial value of 330. That's why the velocity becomes 342 meter per second at 200 degrees Celsius temperature. Now we will understand how bats fly in the darkness. A bat fly in the darkness in a process called echolocation. So what is echolocation? Echolocation is the determining the location and finding the path by producing ultrasonic sound and by detecting the echo of it. Here we see a bat is producing an ultrasonic sound, and from the obstacle the sound is reflected towards the bat, and the bat can recognize from which direction the reflected echo is coming and how much time is required to capture the echo, and from these calculations the bat can understand in which direction the obstacle is present and at what distance the obstacle is present, and by a very much sharp calculation in its brain it can determine the position of obstacle, and it can find the free path along its path of motion. And this echolocation process is also used by bats to find its prey to hunt their food like small insects or birds. Now we will understand the factors affecting the velocity of sound. At first we will discuss about the effect of temperature on the velocity of sound. The velocity of sound in air is proportional to the square root of the absolute temperature that is expressed in Kelvin. That means the velocity in air is proportional to the square root of Kelvin temperature, be proportional square root of T. For per degree Celsius temperature increase, the velocity increases by 0.6 meter per second. As we have calculated an example previously, what will be the velocity of sound at 20 degrees Celsius temperature? The velocity will be 342 meter per second instead of 330 meter per second, because the velocity increases by 0.6 meter per second for per degree Celsius temperature increase. Now we will also understand the effect of medium stiffness and density. We know that stiffness or rigidity is a property of a solid object or liquid object, even of gaseous object, to resist the deformation due to application of force. That means if there is a material which cannot be deformed easily by the application of force. It has a great stiffness or rigidity. So as a material has a great stiffness or rigidity, it has less amount of elasticity. So now we'll understand the effects of these two factors on the velocity of sound. The velocity of sound in a medium is proportional to the square root of the stiffness coefficient Ks, and that is inversely proportional to the square root of density. That means V proportional square root of stiffness coefficient, and velocity is inversely proportional to the square root of density. So from this we can understand that the sound travels slower in a spongy, that means highly elastic material, and denser material. So in highly elastic and denser material, the sound will travel slower, and that sound will travel faster in rigid material and less dense material. And what is the effect of humidity of air on the velocity of sound in air? Humidity of air has a small effect, but that can be measured on the velocity of sound in air. If there is water vapor present, which is lighter than air, so what will happen then? We know that water vapor has a low molecular mass of 18 compared to the molecular mass of air, about 29. So the water vapor is lighter than air. If water vapor is present to great extent in the air, then the density of this air mixture will be decreased. And we also know that if there is decreased density, there is increased velocity of sound, as we know that the velocity of sound is inversely proportional to the square root of density. So decreased density of air results in increased velocity of sound. So there are two questions for you. The first question is, between hydrogen and air, where is sound velocity higher? Between hydrogen and air, where is sound velocity higher? We know from the table that is given in your book that hydrogen, in hydrogen the velocity is highest, is more. Why? Because hydrogen is less dense than air. Hydrogen is very much lighter and very much less dense than air. Hydrogen has a molecular mass of 2, where the molecular mass of air is about 29. So hydrogen is less dense, there is high velocity of sound. Another question, between diamond and iron, where is sound velocity higher? So between iron and diamond, we know that in diamond the velocity of sound is higher. Why? Because diamond is much more stiffer or rigid material than iron. Now we will solve an example from your textbook, page number 23. The question is, at a certain place, the temperature in the winter is 10 degrees Celsius and the velocity is 332 meter per second. If the temperature is raised to 30 degrees Celsius in the summer, then what will be the velocity of sound? So for this we can assume the first case and the second case. So in the first case, the velocity of sound is proportional to the square root of the temperature in the first case, and in the second case the velocity is proportional to the square root of the temperature in the second case. So V1 proportional to the square root of T1 and V2 is proportional to the square root of T2. So the first and second equation, if we divide the second equation by the first equation, we get a formula V2 by V1 equals to square root T2 by square root T1. Then we can find the velocity in the second case, V2, as 343.53 meter per second. Now let's revise what we learned in today's class. We understood what is called the reflection of sound, the phenomenon of bouncing back of sound by getting obstructed to the surface of separation between two solid, liquid or gaseous medium. And the reflection of sound can produce either one of the two effects called reverberation and echo. We have also derived an equation to determine the minimum distance to hear echo, and we also determine the minimum distance to hear echo at 0 degrees Celsius temperature or at 20 degrees Celsius temperature. And we also understood how bats fly in the dark and the factors affecting the velocity of sound. Due to increased temperature, the velocity increases. Due to increased humidity, the velocity also increases. And if there is density increases, the velocity decreases. And if we take a much more rigid material, stiffer material, then the velocity will also increase. So at the end of today's class, you have a homework to solve the example of your textbook, that is page number that is present in the page number 23. So the question that we have solved in our discussion, this is also for your homework. সো আজকের ক্লাস এখানেই শেষ। সবাই ভালো থেকো ইনশাআল্লাহ। সুবহানাকা আল্লাহুম্মা ওয়া বিহামদিকা আশহাদু আল্লা ইলাহা ইল্লা আনতা আস্তাগফিরুকা ওয়া আতুবু ইলাইক। আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।